So here we've got a bunch of system of equations where we're dealing with 5 variables. So that's why we have subscripts x1, 2, 3, 4, 5 as opposed to using x, y, z, w, stuff like that. So here we are to use a method of reduction to solve this linear system and display the reduced form of the augmented matrix. So basically, we're going to be solving for these variables, and right off the bat we can see that because we only have 3 equations while we have 5 variables, we will have to borrow parameters in order to describe our solution, because there is no other way. If we want to have a specific unique solution, we need to have same number of equations as to the number of variables. But here number of equations is less than the number of variables, which is 5. We only have 3. That's why we need to use parameters. And so we will see how we do this. So first we need to solve this by using augmented matrix. So we set up augmented matrix like this. We take the coefficient, so we have 1, 6, 0, 0, 4, -2, so equal sign replaced by the bar, and the constants on the right side go after the bar. Here we take the coefficients 2, 12, 1, 0, 11, which is equal to -3. And then we've got -6, -36, -1, 1, -22, and it is equal to 13. So these are quite easy to work with. First of all, we can multiply the second row by 3, add on to the third. So this will be then 0, this will be 0, multiply by 3, add on to that gives us 2, 1, multiply by 3, add to that gives us 11, bar, multiply by 3, add on to that, which is 4. As for the first and the second, obviously it's twice as much, the second row. So we can multiply the first row by 2 and then subtract from the second row. So we will have 0, 0, 1, 0, 3, because 11 subtract by 8, which is 3. -3 subtract by -4 is going to equal to 1. And in the first row, we can just write as it is, so 1, 6, 0, 0, 4, which is equal to -2. Then now we scan through and see if there's anything else we can eliminate. There's nothing we can eliminate as to the first row, so this will stay as it is. Now scanning through the second row, we see that there are still 2 numbers on top of the other. So we can multiply the second row by 2 and then subtract from the third row. So that will give us 1, 6, 0, 0, 4, -2, 0, 0, 1, 0, 3, which is 1, and then multiply this by 2, subtract off, so this will be 0, that will be 1, 11 subtract by 6, which is 5, 4 subtract by 2, which is 2. So here we've got our solution. So what we do is, this is x1, x2, x3, x4, x5. So here you see 1, and here you see 1, and here you see 1. So whenever you don't see that, there's the same thing, then you need to use this row and that row as the parameter. So we say that x2 is going to be say r, and x5 is going to be say s, where r and s belong to any real number, and then we describe the rest in terms of them. So x1 is going to be, notice that this was just coefficients taken off, so equal to that. So if you're trying to look at it from this side, everything has to move over to the other side. So we will have -2, -6, but it's x2. x2 is equal to r, so we say r. 4 moving over to the other side because we want to isolate x1 by itself and describe that answer in terms of these 2 parameters in addition to other numbers. So 4 moves over, becomes -4, and it's 4x5, so x5 is equal to s, So this is how we express the first solution for x1. x2 is here, then x3, which is the second one. Then we only have 3, so that's equal to 1 minus, because we're moving this to the other side of the equation. And because it's x5, this will be 5s. And x4 is going to be where we have the next yellow circle. We only have 5 to deal with, so we've got 2. We move this to the other side, so it's minus 5s. So we describe x1, x2, x3, x4, x5, whereas x2 and x5 needed to be expressed in terms of parameters. And that is why we also express the other variables also in terms of parameters, a combination of r and s, and for the other we just needed to have s. And so this is how you transport a system of equations into an augmented matrix, and then from there doing row reducing by various operations. And then once you reduced as much as possible where you cannot reduce anymore, then you recognize which variables need to use parameters, and then when you set them up, you can use any alphabet that is not equal to these. And once you've done that, you can express the others in terms of these two parameters. So when you have number of equations that's given is less the number of variables you need to work with, you know that you have to express your solution in terms of parameters.